They are located on the four corners of the square with side of 10 centimeters. Okay, so this is a two-dimensional problem. So chart 1 is on the lower left. We start with lower left. So here, Q1 equals to what's that? Positive 1 times 10 to the power of negative 3. And Q2 is upper left. So Q2 equals to
Negative 2.
negative 2. Okay. And Q3
Positive 2.
upper right. Positive what?
2.
2. How about Q4?
Negative 1.
Okay, so we have the four charts, and we are going to calculate the resulting net force acted on the upper left chart. So this one. Okay, so we have negative here, positive here, positive here, and negative here. Now, again, this is Q2, then we should have three forces acted on Q2, right? They are provided by Q1, Q3, and Q4. We're going to call them F1, F3, and F4. Okay. But this time, it's a two-dimensional configuration, so these forces will not be along the same direction, same straight line. First, let's determine the direction of force Q1. The force provided by force 1, F1, provided by Q1, acting on Q2. What is the direction? Downward, right? It should be attraction downward from Q1. So it's called F1. How about F3? The force provided by Q3 acting on Q2.
To the right, toward Q3.
To the right, it's attraction, so it should be to the right. Right? How about Q4?
It's negative, so it's away from. Going to the upper left.
It should be like this, right? It's repulsing from Q4, so it's in this direction, right? Okay. So that's three forces. Now you want to add the three forces to get the net force. In this case, it's a vector summation. Okay, you are going to do this vector summation. So let's make a better plot. Okay, so establish some coordinates like this. And then F1 is here, F3 is here, and F4 is here with 45-degree angle, right? This is the diagonal direction, so the angle is 45 degrees. Any question here? Now, what you have to do, you need first calculate the magnitude of F1, F3, and F4, and then do the vector decomposition and vector theory, right? So let's try to calculate F1, F3, and F4 first with magnitude. So F1 equals to K Q1 Q2 divided by R1 2 squared. Okay? So this is 9 times 10 to the power of 9 multiplied by Q1 is 1 times 10 to the power of negative 3. And Q2 with the absolute value is 2 times power 10 to the power of negative 3. And radius, or the distance, what is the distance here between Q1 and Q2? In meter should be 0.1, right? So 0.1 square, 10 centimeter, 0.1 meter. And F2 is also easy. K times Q, not F2, F3. Times Q1, Q3 divided by R 1/3 squared. So here almost the same. 9 times 10 to the power of 9 times charge 1 in
Why is it? Yeah.
Q2. Okay, we are calculating the force acted on Q2. So it's Q2, Q3. So its absolute value is positive 2. And Q3, absolute value is Q2. What is R13 here? The distance. Again, 0.1, right? So this is also simple. Okay, you are going to get the number. And F4 here, it should be the constant times charge 2 times charge 4 absolute value. Okay. Here, what is the radius or the distance between charge 1 and charge 2 and charge 4? 0.2?
Square root of point.
Okay, it's diagonal. What is the base of the diagonal?
Square root of 2.
Square root of
Point
0.1 squared plus 0.1 squared.
Point
So it's actually
2.
square root
2.
of 0.02. Any question here? Or 10 multiplied by.
Isn't it just
square
0.2?
root of 2.
Isn't it just 0.2, not 0.02?
0.1 squared is 0.01.
Oh, is it?
So 0.02 squared.
Oh, okay.
Okay? You can check that carefully. This is square root of 0.02 squared. And don't forget, then in your calculation, the square will cancel the square root here. Okay? The square root is you can't use Pythagorean theorem. And this is from R squared in the equation. And you will get F4. Okay? And then next step will be the standard procedure of the vector decomposition and vector addition. Okay, I hope you still remember these things. You already have calculated F1, F3, F4. You want to find F next. The first thing you need to decompose all of them to get x and y components. So for F1x and F2x, this should be simple. What is F1x? What is the x component for F1? Simply 0. Oh, this is not F1y. What is the F1y? Is it 1?
Negative.
No, we don't have now. If you already calculated F1, it should be exactly whatever number you have here, not 1, okay? So you can write it F1 here. If you have number, just put the number here. Okay. And then similarly, F2x,
F3x?
F3x and F3y. F3x will be, F3y will be 0. And F3 will be F3. Whatever number you got from this calculation. Okay. And for F4, we have to do decomposition. F4x, can you see that it will be negative F4 multiplied by cosine 45 degrees, right? And F4y will be positive F4 multiplied by sine 45 degrees. Okay. Any question here for the decomposition? And then the next step is combine the three to give you F net x equals to F1x plus F2x plus F3x plus F4x. net y equals to f1y plus f3y plus f4y. So if you add these numbers, then you get the x and y component for the networks. And then how do you get the magnitude for the network? Square root of f net x squared plus f net y squared. Right? So I will leave those calculations for you to finish. So here I just sketch out the main steps you are going to do. In fact, I guess this should be something you're very familiar with.